you have a function, f of t, any function, the way we write the Laplace transform of that function is to write it like that. Right? This is just notation. As with any other section of work, when you start new, you start off with what the notation looks like. Yes? So you can understand what is going on. Right? This is the format we're going to use. That can be written as f of s. So you see, you start off with a t value, where t is your variable, and you move to where s is your variable. Right? Another way to write it is like that, or like that, or like that. Right? Depending on the book that you use. But I'm going to use this notation up here. Yeah, and the book that you've got also uses that notation up there. Yeah? Like with everything else, there's always more than one way to write something. Okay? The reason I'm giving you this is so that you know when you read the book and you come across this notation here, for example, you know what it is. Okay, now, the Laplace transform is defined as this. Yeah. Right? It's defined as this. Now, why it's defined like that is what they learn in applied mathematics, pure mathematics. We're not interested in that. Right? You are not also going to be using the transform in this form. Right? So, this is what it's defined as. And you'll find we're going to be using a table of standard forms. And all of that table of standard forms is derived from this here. Right? It's the same as when we started with differentiation in S1. You remember S1? Yes? You started off in differentiation, you started off with differentiation using first principles. Right? And then from those first principles, you moved on to using a table. And all the information on the table that you use to find the derivatives is based on those first principles. It's the same thing here. Right? So this is the maths that the table is based on. You will see in your book, to page over, page 114, you will see at the bottom, transforms of elementary functions. Now there are a couple of them. Those are all derivations. Alright, some derivations, which we're not going to go through. Alright? Because you don't need to know them. No. We are only going to focus on the computation. We're not interested in the derivation. Okay? Now, that Laplace transform will equate to some function of s. Right? And if you think about it, it would make sense that your answer here won't have any t variables in it. Why? They can't see your face on the camera. Eh? You can see in your final answer here, you're only going to have variables of s, no t values, no t variables. Why is that? Say yes? Yes, you transfer it to the s domain, but because you are integrating, someone said in front. Yeah? Because you are using the definite integral integral here. So if I look at an example to show that. Take for example, we've got e to the between naught and 1 st t dt, right? That over there is equal to t. Right? If you solve this, that there tells you that your variable is t, which means that s is constant. Right? If you evaluate this integral, as we did a lot of in Fourier series, that is going to be e to the minus times half t squared. Of course, it's not going to be as direct as that because you've got the variable in that power as well. Right? But say you get some solution, because you're going to have to do this by parts. Right? But say you get some solution, that's not going to be the solution. Between 0 and 1, you would then substitute all your t's for your interval. Right? Which means when you finish, you're only going to have s values there, only s variable. Okay? And that is how you can move from t, where you've got t variables, to s variables. Right? Okay. Yes. That's just to know. You're not actually going to use it like that. Okay, so let's do some conversions between those two. Page to the back of that book. All the way to the last page. Right at the back. You see you have a table, and it says table of Laplace transforms. We're going to be working with that table quite a lot in the next few weeks. You will use it both for Laplace transforms as well as for inverses. Right? You will see on top of that table it says you've got a function, and then they tell you on the other side. Right? Something like that. Okay? So I'll tell you what the explanation will be. In one of the examples, we'll use it. Right? So you are given a function. Right? If you look at number 1 on there, they tell you k or k t to the north. Right? Then they tell you that the transform of that is going to be k over s. Right? So you are moving from t to transform. When we do inverses, you're going to move from transform to t. You use the same table both of them. So, an example would be, if you have a function of 2, right? Your first table says, the first one in your table says that k is a constant value. So the transform of that is going to be this. 2 over s. Alright? So you've changed this function to 2s. So you've moved from where t is your variable to where s is your variable. Okay? Another example. We have function 5t. Look on the table. Which one? Are you sure? Why? It's t to the power 1, not t to the power no. Alright? So that over there is going to be f of t 5 multiplied exclamation. Factorial. Exclamation is a factorial. It's on your calculator, so of course you understand what it is, yes? No. Okay, so firstly, I want to show you when you do the Laplace transform of 5t. So if we have transform of 5t, that's the same as that. Right? The same as with differentiation and the same as with integration. The constant can be taken out of the transform. Okay? So, factorial. 1 factorial is the same as 1 times 1. 2 factorial. 10 factorial. 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1. That's why we have calculator. 200 factorial. That's a lot. And then you make a mistake in the middle of it.
It's a math error.
It's a math error. Okay. Right, so let me give you to do. Yeah? So all we're doing today is trying to figure out how to use that table. It's going to become extremely important because you will find, that will be exercise, the last one I'm giving you today. You will find that sometimes the functions that you are given are not in the form that's on the table. So you must first change it into a form that you can find on the table. Right? And that's what makes these things a bit complicated. So you'll see in the next 2 weeks or so, we're going to do a lot of tutorial type work in all of the classes. Okay? Because there's little tricks that you need to pick up